can I ask question?
Yeah, I will take that question in between some time. Okay. If we are approaching, or if I am done with my agenda, or if I
Sir,
am
my
ahead
question
of
is
time,
related to week 6, sir.
week
So,
6, I will take it. Okay. Don't worry.
so you are going to deal about this floor functions in this session,
Sure,
revision
sure,
session.
sure.
I
See, whatever I'm going to discuss in this session, that will definitely help you in preparation of your quiz too.
because they're asking many questions in
Yes,
about
yes.
floor.
I have the question.
Okay, thank you.
Okay. Okay. So let us start then. Let me complete it this quickly, and I will take the questions at the end. Okay.
But sir, one question was week 6. Can you please tell me?
So
Then
what
you
is it
can start.
related to? See, I will tell you quickly. What is the question is about?
Week 6, activity 6.7, week question number 2.
Topic.
Is a
What topic
uh,
is?
topic is logarithm equations. Logarithmic equations, sir.
Is it
Related
finding
to.
solution of logarithmic equation?
Yes, sir, but I in some I don't understand, so I will
Okay.
tell you.
Don't worry. If the question is related to logarithmic equations, I will take it at the end. It's not that necessary.
Okay, sir.
Yeah. Okay. Then let us dive into this week 7. So we will start with what is the limit of sequences. So if you have a sequence of real numbers like this, please everyone be on.
Brown.
Okay. So like if my sequence is A1, A2, if I have a real number sequence, these are all real numbers. A1 is the first term, A2 is the second term, like this. If I have a real number like this, as n increases, so if we keep on increasing n, that means if I see the 100th term, 1000th term, like this, if as n increases, if these real numbers, if these later real numbers comes closer and closer to some real number a, so if it is coming to some real number a, then this particular sequence an is said to have a limit value a, or I say the limit of a sequence an is equal to a, like this. So simply this is what it says: as n tends to infinity, if an is tending to a, and this a should be unique. When I mention unique, that means it should, this particular sequence of real numbers should approach to one single real number, a unique real number. So if it is tending like this, then I can write it, I can write the whole thing like this: limit n tends to infinity, an is equal to a. So whatever the sequence I give you, if I say an is equals to 1 by n, so this is one sequence where nth term is equal to 1 by n. So what will be the first term? 1 by 1. 1 will be the first term. So what are the real numbers that lies in this sequence? 1 half, 1 by 3, 1 by 4, and so on. So first term is 1, second term is half, third term is 1 by 3, 1 by 4, like this. This is a sequence of real numbers, and this particular sequence, as I keep on increase my n, like 1 by 100, when n equals to 100, my 100th term will be 1 by 100, my 1000th term will be 1 by 1000. You can see my an, this particular real numbers, if I keep on increasing my n, this will tend to 0. This particular sequence will tend to 0. Therefore, I can write this as like this: limit n tends to infinite, 1 by n, this particular sequence will tend to 0. Like this. This is what a limit of a sequence means. If I have given you a sequence, if that particular, in that particular sequence, if I find the limit as n tends to infinite in that particular sequence, if I am getting a single unique real number output, then I say limit of a sequence exists. And if limit exists, that particular sequence is called as a convergent sequence.
So does n have to be a natural number or can be also real numbers? For
See,
a
n
n.
is a natural number here. N is actually the terms. See, first term, second term,
Yes. Yeah, so
third.
n has to be in
Yeah,
natural numbers only.
n belongs to set of natural numbers minus 0.
Because I think there was a question where it was written which of these are sequences or not. So there was a function of r onto r and r positive onto r and r negative onto r. So those functions were not, some of them were not sequences.
Yeah. See,
How do we decide on that?
that depends on this n itself.
Sorry, on the?
N. So sequence means you should have countably infinite. So you can count it. This is the first number.
Hmm. Okay.
This is second, third, fourth. But you cannot get the number of count. But actually you can count. That is called countably infinite. So don't
Oh,
worry. We don't need those terminologies here.
okay.
But sequence means it actually starts with one number, and you can arrange the numbers in a sequence. So first term, second term, third term. If you can able to arrange the real numbers in a sequence, then those set of real numbers can be arranged in a sequence, and they are called as sequences. Okay. Yeah. So convergent sequence is same as limit of a sequence exists. So if limit exists, if for a sequence if limit exists, then it is called as a convergent sequence. If the sequence is a convergent, then obviously the limit of the sequence exists. So it is both sides. Okay. So let us come to what if limit does not exist, or in which cases limit will not exist in a sequence. So if as n tends to infinite, if your an is tending to plus infinity or minus infinity. So for example, if I have a sequence like this, an is equals to n. So as n tends to infinite, my sequence will tend to plus infinity, right? Correct. So what is the
Yes,
sequence?
yes,
An is equals to n. How will the sequence look like?
divergent.
Yeah, 1, 2, 3, 4, 5, and so on. So as I keep on increase my n, I will not converge to, or I will not come closer and closer to some real number. Actually, it will tend to plus infinity. So if you see, the 100th term will be 100, and 10,000 term will be 10,000. 1 lakh term will be 1 lakh. So it is never coming to closer and closer to some real number. It is diverging to plus infinity. So these type of sequences, if I have these type of sequences, I say limit does not exist for these kind of sequences. And if limit does not exist, then I will call it as a divergent sequence, which is opposite of convergent. So if it is not convergent, it is divergent. Okay. So in this first case, so if an tends to plus infinity or minus infinity as n tends to infinite, then we say limit does not exist for a sequence. And there is another possible case where limit might not exist. So if an approaches to two more than one real number, so if an is approaching to some two or three real numbers as n tends to infinity, in that case also we will say limit does not exist for a sequence, for that particular sequence. So you can see there are many examples: minus 1, 1, 0, minus 1, 1, 0, minus 1, 1, 0. So this is a sequence of real numbers, but we cannot actually say, as I keep on increasing my n also, this particular sequence will never come closer and closer to one unique single real number. This will actually come closer and closer to three real numbers, which is minus 1, plus 1, 0. So sometimes it goes to minus 1, sometimes it goes to 1, sometimes it goes to 0. So it is approaching to more than one real number. So in these type of cases also, we say limit does not exist for this sequence. So these are the only cases where limit does not exist. And in most of the 95% cases, limit exists and it will approach to some unique value, unique real value. Yeah.
Sir,
Yeah.
sir, can you please once again explain the convergent and divergent once again, please?
Okay, it's just the terminologies. Okay, if limit exists, we say it is a convergent sequence. If you can able to get this particular limit value is tending to a unique real number, then we say limit exists. If limit exists, we give a name to that sequence, or we will keep it in one separate class, and that class is called as a convergent sequence class. So whatever the sequence is present in that class, we call them as a convergent sequence. So the term, the name is convergent. That means it converges to some real value. It is coming closer and closer to some real value. That is just the term. Don't worry about the term.
In case of divergent, when it tends to, let's say, positive infinity only, in that case, limit does not exist because it
Yeah.
does tend to infinity, right?
Yeah, limit does not exist. See, these are two cases. So I have written it in single case. So either if an tends to plus infinity, or if an tends to
Okay.
minus infinity, we say limit does not exist for the sequence.
Okay.
Yeah. So those are just terms. So the convergent, divergent is just the terminology we define. So if limit of a
sir,
sequence exists, it is convergent. If limit of a sequence does not exist, it is divergent.
so sir, when the limit value is goes to 0, so
Hmm.
that means limit does not exist.
No. 0 is a real number. So I haven't mentioned here, right? Either plus infinity or minus infinity, or it is tending to more than one real number. Those are the only cases. Okay.
No, sir, I'm asking when we find the limit right hand side and left hand side, and we goes to the answer is goes to 0. That means limit exists at 0. The value is 0.
Yeah, the limit exists and the value is 0. Correct.
Okay, sir.
So in this case, you can see, right? This is one case. Limit n tends to infinity 1 by n. 1 by n is approaching to 0. So we say this particular sequence is a convergent sequence, or limit of that sequence exists. That's it.
Okay, thank you.
Yeah. Now let's see the properties of limits. So if I have two sequences, an is tending to a and bn is tending to b, or I can write this as like this also. So limit as n tends to infinite, an is equals to a, and limit as n tends to infinite, bn is equals to b. So I have two limits, two sequences, which actually converges to two different real numbers. Now in those cases, if I have like this, there are few properties of limits such that if I add these two sequences or subtract these two sequences, even the newly formed sequence, which is an plus bn or the an minus bn, will also tend to, or will also comes closer and closer to a plus b or a minus b. So what it says is, if I compute the limit n tends to infinity an plus bn, I can actually split the limits like this: an plus limit n tends to infinite bn. So limit n tends to infinity an is a, and limit n tends to infinity bn is b. So that means limit n tends to infinity an plus bn will give me the value a plus b. So that is what this property says. So similar kind of thing works for a minus also. If I subtract two sequences also, the limit of the subtracted sequence an minus bn will tend to a minus b. Okay. And the next property is, if limit n tends to infinity, an times bn will tend to product of the limit values a times b. This is. And the third one is, if I multiply a real number to my sequence, any real number c to my sequence, So C times an, you can write it as, you can bring out C, whatever the constant value, you can bring out the C outside the limits. Like this, C times limit n tends to infinity an. So C times this particular thing is equal to A. So this will be equal to C. And the fourth one is, for quiz 2 it is not important, but when it comes to properties of limits, this is an important thing. If f is a polynomial function, so you know what is a polynomial function is, right? If f is a polynomial function, let's say n square, a quadratic function. So f of an is nothing but an square plus an plus 2, like this. This is a quadratic function. So this particular f of an, or this limit, okay, limit n tends to infinity f of an, actually I can write it as limit n tends to infinity an square plus an plus 2. Now you can split the limits. Limit n tends to infinity an square infinity an plus limit n tends to infinity 2. And this particular limit will tend to a square plus limit, this is a and this is 2. And this will be equal to f of a. Okay. This actually tells you that if you have any quadratic or any polynomial function, if you wanted to compute the limit of that particular newly formed polynomial function sequence, you simply substitute the limit value of an in place of limit value of an a in place of a. That means you simply substitute a in place of this a. That will be the limit value of f of a. Okay, we will see an example of that also.
Sir, can you please example for question number 3, option A, properties 3 also?
Example.
Yes, sir.
You can see, right? Limit 2 by n.
Hmm.
Okay. This is nothing but 2 times limit n tends to infinity 1 by n.
Okay.
2 times 0, like this will be 0.
So, I have a question. If -1 by 6 and -7 is an increasing sequence or decreasing sequence?
-1 by 6 and
-5 मतलब डिनोमिनेटर में 6 and -5 है. -1 upon 6 and -5.
this is right. This is the thing. -1 upon 6 and -5.
This one is an increasing sequence or decreasing sequence?
You can actually find increasing sequence or decreasing sequence by giving n equals to 1, n equals to 2, n equals to 3, like this. The substitute, what is the first term will be -1 by 6 times 1 minus 5. Right?
It will be always negative, right?
This will be -1. Okay.
Decrease.
Just substitute 6 is equal 6 times 2. Or you can see here, right? As n takes larger and larger values, this particular denominator value will keep on increasing. And -1 by larger values will keep on decreasing.
But sir, somewhere in question, they showed it key increase. That one is the increasing sequence.
Right, correct.
Sir, it's an
Sorry,
increasing
it's an increasing
sequence.
function only.
Yeah.
Wait. So the thing -1 by, right? Look at the minus.
Your questions. He's adding next time. He's adding another session. Shrikant will take another session at 10 o'clock. Please, it's good. If necessary, only we will ask the questions. Let him complete the syllabus, please.
Yes, that is better. So don't worry about this thing. Okay, I will take these questions at the end. So let me complete my.
Sir, all these properties will be applicable whenever n tends to infinity only.
Yeah, wherever n tends to, see what limits of a sequence we are going to find only for n tends to infinite. So if I have a sequence, where will my last terms means when n is tending to infinite, where will my last terms will tend to, whether it is going to some real number, or whether it is going to plus infinity or minus infinity, or whether it is going to some more than two real numbers or so. That is what we are going to check in a limit of a sequence.
Okay, sir.
Every time it is n tends to infinite only.
And so n is always positive, right?
N is always positive and starts from 1 and n goes till infinity.
Okay, thank you, sir.
Okay.
So in the second property, A and B and
Sir, would we be discussing doubts later on?
Yeah, we are going to discuss doubts.
I have doubt in question from one live session, sir.
Yeah, I will take it at the end. Okay.
Okay.
so in the second property, A and B n tends to AB. So then find the limit both multiply then A and B n values. Then how to find that one?
It's just a product, na? So if you have, I said limit a n is tending to some 2 and bn is tending to some 3. Limit a n bn will tend to 2 times 3, which is 6. That's
Okay.
it, nothing.
So is it given AN and BN
Yeah,
separately?
it is given. This is given.
Oh,
A and B
okay.
are known values. Okay, we know A and B values.
Or is it something fine when in the question? So then we multiply both of them and
Yeah, that will be the answer. Okay, now let's see some standard limits. So these are all well-known limits to us. So n tends to infinity, 1 by n will tend to 0. This is a very good standard.
Sir, on the limit n tends to infinity, a n square become a square. Limit n tends to infinity, a n square become a square.
I'm unable to hear him. Is my connection bad or?
No. The voice is breaking.
Okay.
His voice is breaking.
Okay.
Sir, you please take the questions at the last, sir.
Right. So once I complete the topic, then I will take some 2-3 doubts, major doubts, and I will move to the next topic. Okay. So let us see this. One standard limit is limit n tends to infinity, 1 by n will tend to 0. If you forget this, then forget your 20 marks. Okay. So this is one good important standard limit. So you try to remember, or it's very easy to see. As the denominator approaches to infinity, this particular 1 by n will go to 0. And the other limits are like, there are few more standard limits. N power 1 by n as n tends to infinity. This will be in the form of infinity power 0, and this will tend to 1. And the other is 1 plus 1 by n to the whole to the power n when n tends to infinity. This is also another sequence. This will tend to e. Okay. And yeah, this is most important one. Okay, now let's see solve some examples of this. So if I have given you a sequence like this, and if I ask you to find the limit of the sequence, what is your very step one? Like how will you
Divide by
start?
n square.
So take n squared common.
Square common.
So you take the highest degree common from numerator and the denominator. So I have to find limit n tends to infinity an. So I have to check whether this limit exists or not. So in order to do that, I take highest degree is n square 2. Highest degree is 2, so I should take n square common. I take n square common from the numerator. This will be 6 minus, when I take n square common, this will be 1 by n plus 4 by n square. From the denominator also, I will take n square common, minus 2 by n square minus 3 by n plus 2. Correct? This is how it will be, right? So if I take n square common from the numerator and the denominator, this is how it will look.
Yes.
Now I can cancel out n square and n square. Now my limit, you can see, I have already told you, you have to remember that limit n tends to infinity, where will this 1 by n will go to?
0.
Okay. Now if you see 6 minus 1 by n plus 4 times 1 by n square divided by minus 2 times 1 by n square minus 3 times 1 by n plus 2. If you see here, as n tends to infinity, this particular term will go to 0. This particular whole term will go to 0. You observe this is 1 by n square. If 1 by n tending to 0, 1 by n square will also tend to 0. So this will also tend to 0. This will also tend to 0. This will also tend to 0. Now what we are left with is, in the numerator we have 6 and in the denominator we have 2. So what will be the answer?
3.
Correct. So this particular sequence an, as n increases,
-2 na? Sir, only 2 or -2?
only 2, right? You take n
Plus
square
2.
common.
2
You take
only.
n square common. This will be minus 2 by n square minus 3 by n. This plus 2. This plus 2 will be remainder. Okay. Be careful with plus minus. Okay. So this will be 3. So this is how you solve the problems. Okay, let me take another example. So previous example is like whatever the n is, whether it is even or odd, it is going to take the same this particular n square minus n plus 4. Like. But now there is a new sequence where it depends on the n. If n is even, it takes 4n plus 3 in the form of 4n plus 3 by 1 minus 4n. If n is odd, it takes in the form of minus 4 minus 6n square by 6n square plus 5n minus 9. So the question is, first and foremost question is, whether the limit of the sequence exists or not. If it exists, what is the value of the limit? So how do we approach this kind of problem?
Sir, here it does not matter if n is even or odd. If the limit exists, both of them should go to the same value. So we'll just check that when n is even, if it is tending to, suppose when n is even, it approaches some value c. And when n is odd, it also approaches c. So in both the cases, it approaches the same values. So we can say that bn exists and the value of bn is c. But if they approach to different values, then the limit does not exist.
Correct. Correct. Exactly the same statements which I'm going to tell you. So in these kind of cases, what you do is, you check for the case of even, what you have to check is, when n is even, you check the limit n tends to infinity of bn, which is limit n tends to infinity 4n plus 3 by 1 minus 4n. So you check the limit of this. What is the limit value of this?
-1.
Minus 1. So if you are not aware, just this is the highest term. So n to the power 1 is the highest degree. Just take n common. To take n common, this will be 4 plus 3 by n. And this will be, if you take n common, 1 by n minus 4. Now n and n will get cancelled and this will tend to 0. This will tend to 0. We will be left with 4 by minus 4, which will be minus 1.
Sir, we cannot do it without taking the n common out, is it? Because if we don't, it is giving a different number.
Of course, it will give you the wrong answer. You will get something like infinity by minus infinity form. So how will you do? So if I say this is infinite, this is n is going to infinite, that means numerator will go to infinite.
Oh, the whole point of taking the highest degree outside is to convert it into the denominator form, 1 by...
Yeah.
Oh, okay. Because it will be 0. Okay.
Yeah. So this will go to minus 1. So now what we have to check is, we check for n is odd case also. If n is odd, you check the same thing, n tends to infinity bn, which is limit n tends to infinity 4 minus 6n square by 6n square plus 5n minus 9. Now tell me what is the limit of this?
-1 again.
-1 again, yeah.
One again.
-1 again, right? So numerator you will get -6, denominator you will get 6. We are getting -1 again. So
Yes.
in these cases, if you are going to get the same value for both the cases, if you are going to get when n is even, you are getting -1, when n is odd, you are getting -1. In that particular thing, limit exists. What we say is limit of Bn exists, and the value of limit is -1. But if you got something else, like if I have given you it here, I have changed this to 3, not 6. What if I have given you something 3 here? Now this will become 3, and this will become 3, and the answer will be -2. So you are going to get two different values in the two cases. So in this situation, what is done is limit of the sequence Bn does not exist. That's it. So whenever the question is given like this, what you have to check is you have to check the two limits. If the two limits are equal and approaching to a single real number, like in this case -1, then we say limit of this sequence exists and the limit value is -1, and this is how we check. Okay. Let's solve another problem.
Instead of taking n square common, can we differentiate directly to reduce time? L'Hopital.
No, L'Hopital rule works for functions, not the
Oh, sorry.
sequence.
But it's giving the same answer.
Okay, is it give? Okay, see, it might give, because here these are functions. If this can be converted to functions. If I replace n with x, see here n is not a real values. N
No,
takes
this is the
discrete
most
values.
easiest method.
Yeah.
Okay.
Okay. Now let's involve some more complicated stuff into this, which is floor. So my first question in this type of problem is, what will be floor n by 2?
N minus n plus 1 by 2.
If n is odd?
Minus n plus 1 by 2.
If n is
What
even?
is this floor called?
N minus 1 by 2.
Okay. Let us solve the first simpler case. If n is even, what will be floor n by 2?
N by 2. N by 2.
N by 2. This is easy, right?
Yes.
Yeah.
So if n is odd, what will be the floor n by 2? Well, in
N
terms of
plus 1 or -1 by 2? N minus 1.
N minus n plus 1 by 2.
No, n minus 1 by 2.
You can check. So you take few values. So n is odd here, right? So I can take 1, 3, 5, 7. So what will be floor 1 by 2 value? Floor
0.
3 by 2. Floor 5 by 2. Floor 7 by 2. So what is this value? 0. This value?
1, 2, 3.
Right. When I substitute n is equals to 1, I should get output as 0. When I substitute n is equals to 3, I should get output as 1. When I substitute 5, I should get output 2. Just substitute 1 here. We are going to get 1 minus 1 by 2, which is 0. When you substitute 3 here, 3 minus 1 by 2, 2 by 2, which is 1. 5 minus 1 by 2, which is 2, like this. So, yeah. So when n is odd, floor n by 2 can be written as n minus 1 by 2. So once you know this, you just substitute n minus 1 by 2 in place of this floor n by 2. Now my new Cn will be n minus 1 by 2 minus 4n divided by n plus 3 if n is odd, 4 minus 7n divided by 6 plus 2n if n is even. From here it is the same example 2. So what we did in example 2.
We can't tell you mute all once disturbance is coming.
Yeah, sure. Okay. So when I substitute n minus 1 by 2 in place of floor n by 2, this is how my sequence looks like. And I can simplify this further also. Just substitute this 2 and bring that 2 to the denominator. This will eventually, you will get minus 1 minus 7n by 2n plus 6. Just simplify this term, you will get. If n is odd, 4 minus 7n divided by 6 plus 2n if n is even. Now everyone quickly solve this and tell me whether limit of this sequence Cn exists or not. If exists, what is the value of Cn?
Minus 3.5.
Exists, right? You check for two different cases. You take the two cases, n is odd and n is even. You check when n is odd, what is the value you are going to get?
When n is even, should we substitute n equals to n by 2?
No, nothing. There is no floor n by 2 here, right? We only have floor n by 2.
Okay, sorry.
Here.
3.5.
Both give minus 3.5.
Minus 7 by 2.
Limit exists, sir.
Just check this. You will get minus 3.5 in both the cases. So you take n common from the numerator and denominator, you are going to get minus 7 by 2 when n is odd. Same works for here also. You take n and n common. Minus 7 by 2 minus 3.5 you are going to get. So therefore I say limit n tends to infinity Cn is equals to minus 3.5. Okay. So if I ask you Cn, it is okay. What if my question is find the limit of the sequence of 2 times Cn?
Minus 7.
Minus 7. Minus 7.
Okay. If I ask you the sequence of Cn, if I newly define a Dn, I say Dn like this, something like 2Cn square plus some Cn. So like this, if I define a new sequence, which is a function of Cn, which is a polynomial function of Cn. Now what is the value of?
Just put the limit.
Equals to minus 3.5, we should substitute.
Yeah, just substitute 3.5. 2 times minus 3.5 whole square plus minus 3.5. You compute this value, that will be the limit of this sequence, new sequence Dn. Okay, so remember this. So in the mock, I have taken the mock question itself. So this is very important and standard one.
Sir, can you
21. Answer is 21.
explain once again, sir? The last step, the 2Cn.
This one.
Yes, sir.
You just substitute. So if I wanted to find the limit of this new sequence Dn, you just substitute limit value in place of Cn.
Can you repeat that step after n minus 1?
Which is n minus
After solving minus 3.5, how we can calculate Cn?
Okay. How you can calculate 2Cn?
Minus 3.5 मतलब यहाँ तक समझ में आया सर, जहाँ हम लोगों ने वो दोनों वैल्यूज को कैलकुलेट किया. After that, how we can write minus 3.5?
ये दोनों का वैल्यू कितना है? What is the value you got?
Yeah, that is the value minus 7 by 2, minus 3.5.
Take out n and calculate.
You got minus 3.5. Did you got minus 3.5?
No.
Minus 7 by 2.
I got the minus 1, minus 7, even और odd के लिए जितना solve किया यहाँ तक आया. After that, I didn't get.
Okay, you just take the example 2 kind of thing. Just take two different cases, n is even, n is odd. Find the limit value. So when n is odd, you have this thing, limit minus 1 minus 7n by 2n plus 6. So how do we solve these cases? Just take n common from numerator and denominator. Correct? Numerator से n common लिया तो minus 1 by n minus 7. Denominator also, if you take n common, you will get 2 plus 6 by n. Now this particular thing is tending to infinite. This and this will get cancelled. This will tend to
This one
0.
is
This will tend to
3.5.
0. This is minus 7 by 2. This is minus 3.5. Similarly, check for this also. Check for the second case also. You will get minus 3.5. So once we are getting the same value, we say limit n tends to infinity, Cn
Okay,
is
sir.
equals to minus 3.5. Once you got this limit n tends to infinity, Cn is equals to minus 3.5, we have properties of limits. Even if a real number is multiplied to that sequence, what we do is we just multiply the limit value with that new constant value. So that means you just multiply 2 times minus 3.5. You just replace
Why
Cn.
we multiply by 2, sir?
2 because we are not asking the limit of the sequence of Cn. We are asking limit
It's a
of
rule.
2n.
It's a rule. Limit of
2 times
ACN.
of Cn. Okay.
Sir, if this doesn't match,
Hello.
then what will be happen? Limit doesn't exist.
Yeah, if does
Sir,
not.
we will check after this. matlab why we are doing this 2 into and then dn.
That is a question. That is what I asked.
Okay.
The new
That is the
sequence
question I
is
asked.
2cn square plus cn, so we find the value.
Okay, it's like question is find 2cn.
Yeah, find the limit of
Limit. Okay.
sequence to Cn.
Okay.
Sir,
Hmm?
sir, how can I understand that I should replace the odd limit of Cn or even limit of Cn? Like
That
value
is
of
what I said.
even.
There is no odd limit and even limit of Cn. If you
No,
your
there
odd
is a
limit and
if n is odd, n is even.
Both are same, na?
yeah, both
Limit
are
value
same
is
here.
same.
Okay, so there is no odd limit and there is no even limit. If your
So
odd
what do we
and
do
even
if
limits
it's
are
No,
different?
actually, if it is different means limit doesn't exist.
limit does not exist.
That's all. First, you have to check whether limit exists. For that, you have to satisfy both the condition and both the
Okay, I
answers will come.
understand.
Then only we say this. Okay.
So
this
in
is
this
the
question, if the this is the floor function, if this is ceiling function, then n is odd.
Don't
So
worry
what when
about that. See, don't worry about ceiling function now. We will discuss when we after quiz 2 we can discuss a lot.
Okay.
Yeah. So if I ask you like this, then you multiply 2 with your limit value. 2 times minus 3.5. This particular new sequence 2cn is a new sequence. Cn is one sequence, 2cn is another sequence.
Okay, sir. And dn, what is dn here, sir?
dn is also a new sequence which is function of Cn. So
Okay. Okay, sir.
Okay. So we have
Sir, one little bit question, sir. In upper limit question, how will get 2?
How will you get
2? So
yeah.
upper. Scroll up. Yes, sir. ये red point में जो -2 आया sir.
That I if this 6 की जगह मैं 3 लिया तो क्या होगा? That is what I said.
Okay.
अगर 3 लिया तो that will be -2. अगर 6 ही लिया तो that will be
तो सर लिमिट एग्जिस्ट नहीं करेगा तो
नहीं करेगा. -1 -2 दो different values. We got 2 different values.
तो सर हमारा फाइनल आंसर क्या होगा कि लिमिट एग्जिस्ट नहीं करेगा?
Exist नहीं करेगा. Does not exist.
Yeah.
We are getting 2 different values. Limit does not exist.
Okay. Thank you, sir.
So just one point over here, if we put it simply, हम variable के roots निकाल रहे हैं, number theory के हिसाब से आगे चले हैं. I mean, people have all these confusion. Can we link it that way? अगर number system and functions relations कर लें, then limits would be easier to understand.
Even I didn't study that much. See, why are you bringing number
so
system
confusing.
into limit calculus?
Yeah, sure. Calculus is very confusing, sir.
Sequences are nothing but number patterns.
Yeah. Correct. So that is what even I understand. So sequences are just the way we arrange the numbers or
Got it, sir. Thank you, sir.
Pattern, particular pattern.
Sir, what are these floor and ceiling functions? Sir?
Those are some kind of functions. What are polynomial functions? Quarter, quadratic, exponential. In that way, mod function, ceiling function, floor functions.
So what's the difference between a floor function and a ceiling function?
Okay. Do you have to
These
discuss?
proceeds are
Can
Nothing.
you please explain
even
at the
nothing.
end, because we discussed many times this floor functions and
Yeah.
it's there in the video also. It will take
But
lot of
even
time.
graded has questions on floor ceiling.
Yeah,
Yeah.
it will
Don't know
take
how
lot
it's
of
not
time
clear.
to explain if it is the first time. Please move on.
Okay.
We don't have time.
So don't worry about that floor, ceiling.
See, maybe you know everything. There are people from arts and science and bio background. And if you know everything, you can accept. You should respect everybody, ma'am, with all due respect.
Dear, it explained
Okay.
very well in the previous sessions. That's what
We
I
missed it. We are not as knowledgeable as you. And we are working, ma'am.
Okay, let me tell you one
floor
thing.
function and ceiling
Okay, sir. Okay,
function.
sir.
Instead of you both fighting, it's better we move on.
It will
You are
take
either
lot
way
of
wasting
time.
time.
Yeah, we are
It
running
will
out of
take 10
time.
to 15 minutes if he wants to explain floor function and
Thanks
ceiling
for the
function, the
concern.
difficult ones.
Please relax. We have limited time.
Yeah.
Yeah.
Time is running out.
Agree, sir. Thank you, sir.
Okay. So that is how you have to solve these problems. So if a new sequence is given, then what you do is just replace Cn with the limit value you got. Then the new limit Dn will be like this: 2 times of minus 3.5 to the square plus minus 3.5. So if you simplify this, what will be the value? So let's something. So don't be so itna tak ka hai, don't be like yaha galat karo. Don't do mistakes in calculations. Okay, you will lose marks again. Okay, that is how you solve limit of a sequence. Let's move to limits of a function at some point x is equal. So now we are moving into functions. So this is quietly different from what we have seen in sequences. So now we check limit of a function at some given points. So now there is no n tends to infinity or no n tends to minus infinity like that. So at some point x is equal to a, we are going to check whether the limit value of this particular function f of x exists or not. How do we check this? We say there are two types of limits, which is right hand
Could you
limit.
please mute all?
There is a left hand limit and the right hand limit. So this left hand limit means when my x, the value of x tending from left side of the point, to the point, my limit is tending to that, we denote it as a minus. So this is how the denotation goes. When x is tending to a from negative side of a is from the left hand side of the a, where will this function go? Will this function attain a value or not? If it attains, what is the value of that limit? For suppose the value is LHS, subscript LHS. That means left hand limit, L left hand limit. So we are going to get, this is a real number. This L subscript left hand limit is a real number. Let's suppose this left hand side limit is existing and it takes the value LHS. And the same way right hand limit is when the x is approaching from right side of a or from the positive side of a. So a plus. So you start from the right hand side of the a and you start moving towards a. So you see here. So if this is a, this is left side of a, this is right side of a on the number line. You start from here. If it is left side of a, you start from here and you start moving towards a and you check the limit value of the function. And right side of a is, right hand limit of a is, you start from right side of a and you start moving towards a and you check the limit value. So there are two limits. So one is L subscript LHS left hand limit and the right hand limit. So you'll get two values. If these two different values are same, let's say it is equal to L. If the left hand limit and the right hand limit are equal, then we say limit of this function exists at the point x is equals to a, and I can write it like this: limit x tends to a, f of x is equal to L. Okay, if I am writing like this, that implies that limit of this function exists at x is equals to a, and the value of limit is equal to L. If the left hand limit and the right hand limit are not equal, if you are going to get two different values when you approach from the left hand side and the right hand side, if you are approaching a, if you are getting two different values, two different limit values, then we say limit of this function f of x does not exist at x is equals to a. So this is same as the example we have seen in the above, even odd cases. Now there is no even, there is no odd, there is left hand and the right hand. So you check the left hand side limit, you check the right hand side limit. If both the limit values are same, then we say limit of this function exists at x is equals to a. If the both the limits does not exist, if the both limits are not equal, then we say limit of this function does not exist at x is equals to a. Okay. Yeah. So there are some standard limits we know, even the same way how you remember that 1 by n, limit n tends to infinity 1 by n is tending to 0. That is how even you should remember this also. Limit x tends to 0, sin x by x is 1. This is a well known one. And this is important. Limit x tends to 0, e power x minus 1 by x is equals to 1. So this you have to remember.
Excuse me, sir.
Hmm.
So, sir, when a limit exists, it is not necessary that the function will be continuous also, right?
No. Limit. So when I discuss this flow chart, you will get to know. As of now, we are discussing only limits. So
Okay.
if limit exists, you cannot guarantee it is continuous or not.
Okay.
Yeah. So yeah, this e power x minus 1 by x will, when x tends to 0, will take value 1. And similarly, there is another limit, ln 1 plus x by x is also equal to 1 when x tends to 0. And all these limits, if you know L'Hopital rule priorly, by now you know, I guess. So these all can be computed using L'Hopital rule. Okay, so that is about limits, and I will take an consolidated example where limit, continuity and differentiability comes. So that is the most important one. Even in mock there is a question, I guess. Correct? I will take that example. Okay, that is about limits. So as of now we discussed only the limits. So we are going to check the left hand limit and the right hand limit at point x is equals to a. If they are equal, we say limit exists. If they are not equal, limit does not exist. Now we move to continuity of a function at point x is equals to a. Now we are going to check the continuity also. So the condition for continuity is, the first condition you can see here, if the limit of f at x is equals to a exists. So priorly your limit should exist. In order to check the continuity, your limit should exist. And along with that limit existence, you have to check this particular limit value actually should be equal to the function value at that point. So this particular limit x tends to a, f of x, this particular limit value should be equal to your function value at that point. F of a is the function value at x is equals to a. So if these two conditions are satisfied, then f is said to be continuous at x is equals to a. So in addition to the conditions for limits, we have an extra condition that this particular limit should actually approach to the function value at that point. So that is what continuity means. Now we see what is differentiability very quickly. So differentiability of a function at point x is equals to a. So for differentiability, f is continuous at x is equals to a. Now f should be continuous. For continuity, limit should exist. And an extra condition. For differentiability, firstly it should be continuous. So f is continuous at x is equals to a, and along with that, another limit value we are going to check, which is limit h tends to 0, f of a plus h minus f of a by a plus h minus a. So the denominator is nothing but h. You can simplify that. I have written like this. So this particular limit value should also exist. In addition to continuity, you have to check this particular limit value also. If this exists, then f is said to be differentiable at x is equals to a. If it does not exist, then we say f is not differentiable. Okay. So yeah. So how do you check connections between limit, continuity, and differentiability? If you know a complete idea where to start. So if I have given you a function, and if I ask you to check the differentiability, continuity, and limit of that function at x is equals to a, how do you start? So from where do
So
we start? Yeah.
first we find the limit of right hand limit and left hand limit is equal.
Right, correct. So from where we start is we just compute the left hand limit and the right hand limit. L subscript LHS is the left hand limit. L subscript RHL is the right hand limit. Suppose you say you have got two values. If these two values are equal, if these two values are equal, then I say limit exists at x is equals to a. If these two values are not equal, this is true, this is false. If this is false, then you stop. You stop there itself. You say limit does not exist at x is equals to a. F is not continuous at x is equals to a. F is not differentiable at x is equals to a. If your left hand limit and the right hand limit are not equal, then you no need to worry about checking continuity, differentiability, and everything. Once limit does not exist, you conclude these statements also. F is not continuous at x is equals to a, f is not differentiable at x is equals to a, and you stop. So you choose the option, you choose these three options and you will move. If the left hand limit and the right hand limit are equal, then we say limit exists at x is equals to a, and we move forward. So once the limit exists at x is equals to a, we will check whether this limit, whatever the left hand limit and the right hand limit, whether this is equal to f of a or not. Our next step is to check whether this is equal to f of a or not. If no, if it is not equal, then what we finally say is limit exists at x is equals to a, but f is not continuous and f is not differentiable at x is equals to a. Okay. So if your left hand limit and right hand limit are equal, but if it is not equal to f of a, then limit at x is equals to a exists, but f is not continuous and f is not different. You no need to check the differentiability condition here. Once it is not continuous, it is not differentiable. But if it is equal to f of a, if it is true, yes, if it is true, then we say f is continuous at x is equals to a. Once we say f is continuous at x is equals to a, then we are going to check the step 3 comes in. Then we are going to check this particular limit f of a plus h minus f of a divided by h when h tends to 0 exists or not. So depending upon this, if it is exists, yes, then we say limit exists, continuous and differentiable. If this particular limit does not exist, we say f is limit exists, f is continuous, but f is not differentiable at a.
So when do we do LHT, RHT?
What is LIC?
So left hand different. Sir, don't we do left hand different?
See, that is what this thing, right? If exists means, how do you check this particular function when h approaches to 0 from the left hand side, and when h approaches to 0 from the right hand side? If those two are equal, then only this limit exists. If those two are not equal, then this particular limit does not exist.
Sir, will it be possible for you to give an example?
Yeah, I will give an example.
Okay, thank you so much, sir.
Okay, yeah. So only 3 stages of checking. So you have to check whether the left hand limit and right hand limit are equal or not. Once if it is equal, whether it is equal to f of a or not. If it is equal, then this particular limit exists or not. So 3 stages of checking. and each stage you will conclude different things.
So give one example for last term, please.
Yeah, I'm going to take this example now. Okay, so now I have given you a function and there are some unknown values inside it, m, p, n. Okay, what I said is, suppose f is differentiable at x is equals to 0. So if I am saying f is differentiable at x is equals to 0, is it necessary to mention again that limit and
No, because
No, sir.
it is both continuous and limit exists if it is differential.
Yes, sir.
correct. So you have to be aware of this. If I say it is differentiable, then it obviously continuous and it is said that limit exists. From this flowchart, you can actually find it. Just go through the flowchart again. You can actually find the connections between limit, continuity, and differentiability. Now, what I want is find the values of m and p. Use the conditions of left-hand limits, continuity, and differentiability, and we solve this particular example and find the values of m, p, n. Okay.
Can you give an
Shall I give
example
you
of
some?
finding the differentiability also?
Hmm?
Can you give an example of identifying if it's differentiable or not?
In this only, right? We will use the differentiability condition and we will find the value.
Okay. Okay.
Yeah.
Thanks.
Okay. Do I have to give you time or shall we start the time? Shall we start solving?
So we can do it with
Start solving.
Short solving. Okay.
Yes, sir.
So this is how we have to approach. This is how your approach should be. So if it is given like this, you start from the very starting point where we have to check the left hand limit and the right hand limit. As it is said that it is differentiable, your left hand limit and the right hand limit should be equal. So your left hand limit and your right hand limit should be equal. So this both must be equal. So let us compute the left hand limit at x is equals to 0. So x tends to 0 minus f of x.
So, but why do you need to check it? It is already given if it's differentiable.
We are not checking. We are taking that condition and we are finding the values of m and p.
We'll get some
Oh,
equations.
We will
okay.
get some equations. Okay.
Okay.
So this is true. We are not checking. This is true.
Okay. Yeah.
Now we are finding these values. So what is the value of f of x? Which function should I have to substitute when x is approaching 0 from the left
The
hand
first
side?
one.
5e to the power x plus m.
First one, sir.
Yeah. So when x is less than 0, this is how the function behaves. So here also x is less than 0. So limit x tends to 0 minus, I substitute 5e power x plus mx. So what is the limit value? What will be the limit value?
5, sir.
5 plus mx. 5.
5. Similarly, we compute the right hand limit also. So which f of x should I substitute?
Last one.
4x square.
Correct.
4x square minus
4x
3
square
plus
minus
m.
3x plus n. So what is the value of this?
N.
Now see, so the left hand limit is equal to 5 and the right hand limit is equal to n. But we know that left hand limit and the right hand limit are equal, should be equal, right?
Yes, sir.
From here, what we get is my n should be equal to 5.
Equal to 5.
Okay.
Sir, in this question, actually, if you draw a line and if you explain, the people who are little bit left hand, right hand, they can easily follow. Sir. If you
Which line?
Just draw a number line. Yeah. Now, if you explain what is the left hand, what
How negative approaches.
Thank you, sir. That's a valid point.
Yeah. This everybody will start catching. Yeah, what is left hand, right hand, and which equation they have to take.
Yeah. So, okay. Okay. At 0, below 0, my function is behaving like 5e power x plus mx kind of thing. So in this region, it is 5e power x plus mx kind of thing. And at this point, it is p plus 1. And from the right, it is 4x square minus 3x plus n. Okay, in this region. This is in this region. Now see, the left hand limit is
left side of 0.
Left side of 0. So I start from here or somewhere. I will approach 0 from the left hand side. So I'm coming like this. So in this region, my function is behaving like 5e power x plus mx. So I should take f of x as 5e power x plus mx. So but from the right hand side, I start from here and I will approach to 0 from the right hand side. I will come like this. So in this region, it is behaving like 4x square minus 3x plus n. So from left hand side means it is coming from the left side of 0. From right hand side means it is coming from right side of 0. Towards 0. Both towards 0. We approach 0 either from left hand side or the right hand side. Okay. Yeah. So when we compute that, we will get one limit as 5 and another limit as n. But we know that left hand limit and the right hand limit both are equal because the limit exists at x is equals to 0. Therefore, from there we get n is equal to 5. Now the second, so we have checked the limits. Now the second step is this particular limit value should be equal to the function value for continuity. For continuity, x tends to 0, f of x should be equal to f of 0. From the above, what we got is limit x tends to 0, f of x is, so as left hand right hand limit are equal, I can write it like this. X tends to 0, f of x is equal to 5. Can I? Is this
Yes,
true?
sir.
Yeah.
Yes.
Right. So this particular limit x tends to 0, f of x is equals to 5. What is f of 0 given to us?
P plus 1. So P equal to 4.
When x is equals to 0, f of 0 is p plus 1. So you substitute p plus 1. What we will get? From here we will get that p is equals to 4. Correct? So
Yes,
in
sir.
order to be continuous, your limit value should be equal to the function value. Function value is p plus 1 and your limit value is 5. So these both must be equal. So if in order to be equal, p should actually take the value 4. P can only take the value 4.
सर here I have a doubt. Sir, actually मैंने जो solve किया था ना, I was put 5 to the power 5 into e to the power x plus mx is equal to p plus 1. The next equation में मैंने किया था p plus 1 is equal to 4x square minus 3x plus n. I also got the same value like p is equal to 4, 5, n is equal to 5 and m is equal to minus 1. But आपने actually you told in a different way like 5 to e to the power x plus mx is equal to 4x square minus 3x plus n. So sir, you will it give the different values or it will only accidentally I got the correct value?
No. Whatever you did also true. Whatever I did is a standard method. So what you did is you just substituted 0 in all the cases. You just equated it, right?
Yeah, like the first equation, जो 5 e to the power x plus mx is equal to p plus 1. Then again I did p plus 1 is equal to 4x square minus 3x plus n.
Yeah, that is also a valid method. It's not accidental because here the functions are actually in the piecewise they are actually continuous. Okay. These are all smooth functions. E power x, x, quadratics. These are all very smooth functions. This will work.
Sir, can you please explain the same question once again, sir? Please.
This one. Question not yet
yes,
completed. You just check the left hand limit and the right hand limit.
Excuse me,
when
sir.
it comes to left hand limit and right hand limit can be found by substituting function values. Here when x approaches from left side, f of x behaves like this, 5e power x plus mx. So if you compute the limit value of this, you will get 5. Similarly, when x approaches from the right hand side, f of x behaves like a 4x square minus 3x plus n, quadratic nature. It has a quadratic nature. So I substitute 4x square plus minus 3x plus n in place of f of x, and if I compute the limit value, I'm going to get n. But I know that the left hand limit and the right hand limit are equal because limit should exist there. Therefore, my n should be equal to 5. From there, I will get this, and I can write limit of this limit extends to 0 f of x is 5. For continuity, this
Excuse me,
particular
sir.
limit value should be equal to f of 0.
Excuse me, sir.
Hmm.
Sir, for calculating the value of m, I used L'Hospital rules. And calculated on the left hand limit. I applied L'Hospital's rule and I got limit x tends to 0, 5 multiplied by e to power x plus m, because we have differentiated it, and then I put it value of x equals to 0. So I
You are
got
saying about differentiability. Yeah?
So let me continuity वाला concept मेरा complete नहीं हुआ. Why we would do did कि जहाँ तक n is equal to 5 आया, then I understand. After that, why we would do fx is equal to 5?
See, why we put fx is equal to 5 is, and if n is equal to 5, your left hand limit and the right hand limit both are equal, both will be equal.
Yeah.
When your left hand limit and the right hand limit are equal, I can actually write it like this. I have said in the above statements also.
I understand that, sir. I understand that, sir. But why we did like कि continuity के लिए हम लोग 5 रख रहे हैं, तो वो सिर्फ x को 0 करने पे एक लेफ्ट वाले में रख रहे हैं या 5 राइट वाले में रख रहे हैं? दोनों पे रखने पे आ तो 5 रहा है. Sometimes it will not be, then it will not be continue.
It will not be continuous. But here
Okay,
I
sir.
said it is differentiable, right? Once I said it is differentiable, it will be continuous.
Okay, sir.
Okay, that is why we equate it to f of 0. And f of 0 is p plus 1. From there we get the value of p.
Okay, sir. Okay, sir.
Now you check the third step, which is differentiability, where this particular limit should exist. F of 0 plus h, here our a is 0, minus f of 0 divided by h. This particular limit should exist.
Okay.
Okay. In order to check whether this exists or not, we check this thing. So 0 minus, so 0 plus is nothing but h, 0 plus h is nothing but h. And this thing, 0 plus. So if these two values are equal, then only we say this particular limit exists. If these two values are different, then we say this particular limit does not exist, and we say it is not differentiable. But here what it is given is,
So may I ask something? So this is what I was asking about left hand differentiable and
right.
So sir, for left hand LST, isn't the formula different? It's supposed to be f 0 minus h minus f0 upon minus h, right?
Yes, sir.
0 minus h.
Yes, sir.
Yeah, 0
In
minus h.
denominator there should be minus h.
Why?
No, it's same na, a plus h minus a in the denominator.
It is never 0 minus h, it is 0 plus h.
0 plus h. So don't confuse, it is 0 plus h. See,
So
you
there
can
are two formulas.
It's a standard formula, a plus h
It's a
minus h.
standard formula. Here it is plus only.
So okay, so we should
always positive.
So to check this, we should only get a value, and if we get a value, it's differentiable. Okay.
Correct. So when h is approaching from left side of 0, it doesn't change the sign of h.
Okay.
You don't need to worry about the sign of h.
Actually, I saw online. I saw online and I saw another formula.
No. See, if you are comfortable with that formula, you can. If you trust, if that site is a trustworthy site.
Sir, I'll follow your method.
Okay. So
Sir,
don't worry
can I
about
ask
the
a doubt,
signs of
please?
h. So it will always be plus.
Excuse me, sir. Can I ask a doubt? Sir, as in left-hand differentiability, h must be approaching from left-hand side of a particular value.
Correct.
So it must be decreasing the value. But suppose we are taking 3, then if we are approaching from left-hand side, it should be positive 3. So it should be 2.9 and 2.9.1 and 2.9.2. So h must be a value which is decreasing the value of 3, na? We can write as 3 minus particular 0.001. Say we would say that h is approaching 0 when we
here h is always tends to 0.
Okay, sir.
Okay, so you see, I will whatever you said here, our a is 3. You said a is 3, right?
Yes, sir.
Correct. So you started from 2.9. Let's say 2.9. That means your h is minus 0.1 here.
Yes, sir.
You started from minus 0.1 here. You are approaching to 0 from the left hand side.
Okay, sir.
Okay.
So when do we use this first? This is called first principle, no? Differentiability.
Yeah, first principle.
Yes. When do we
So,
use this, or
the
when do
formula
we
is
use
same, the value of
direct
h.
formula? When do we use this
Okay.
first principle, or
See,
when
this
do
is
we
for
use
checking.
direct formula?
Direct formula is that if you are sure that f is differentiable everywhere, then you can use directly then you can directly differentiate.
So, sir, the formula remains
But
the
we are
same, but
not
value
sure
of h
exactly
can be
when to
positive and
use.
negative.
That's it now. See here, when h is tending from minus left hand side, this will be inside part will be f of minus 0.1, minus 0.05, minus 0.25 like this.
Okay, sir.
Okay. Even the denominator will h value will take negative when it comes from the left hand side. No need to give minus in front of it.
Okay, sir. So we are not giving minus, but we know that it is negative. So we
Yeah,
can
it will
just
take
put
negative.
that negative value. Okay, thank you, sir.
Yeah.
So still I'm not able to understand when to apply this and when to apply that.
In order to check the differentiability, you have to apply this.
Every time.
Every time. In order to check the differentiability. If you are sure that it is differentiable, then you can directly differentiate. You can say f dash of x. Okay.
Let's find the value of m. So let's find the value of m.
Yeah. So see, when h is coming from left side of 0, this function is actually taking negative values. So h is less than 0 here. H is less than 0. How will my function behave when my inputs are less than 0?
First equation.
I have f of h now.
First condition.
Where h is less than 0. So which function should I take?
First
one.
Correct. So and replace h in place of x also. This is f of h here. So we will get limit h tends to 0 minus e power 5 e power h plus mh. What is f of 0?
5.
5. You can see f of 0 is limit x tends to 0 f of x, which is 5. Or substitute p is equals to 4, you will get 5. P plus 1 is 5. 5 divided by h. So what will this be? Limit h tends to 0 minus. So look at how I am writing. E power h minus 1 divided by h plus limit h tends to 0 minus mh by h. Okay, I am writing this 5 e power h minus 5. I am taking 5 common and I am writing it like 5 times e power h minus 1 divided by h. I am taking these terms one side, splitting the terms. I am splitting these two terms, and another term is mh by h. Correct? I have did two things in one single line itself. Just is it true?
Yes, sir.
Yes.
Now this h and this h will get cancelled, and this part will be m. And as I said previously also, one standard function limit you have to remember is e power h minus 1 divided by h. That means e
0 to
power x
1.
minus 1 by x when x tends to
1,
0. Where that will tend to
1.
1.
1.
This will tend to 1. Then this particular 5 times 1 will tend to 5. So this will be 5 plus m. So
So
we
can you
got
repeat that once?
Hmm?
Can you repeat that once? What did you say? The
this e power h minus 1 by h. This is a
Yeah.
standard limit.
Yeah, 1. Yeah.
Okay, when h tends to 0, e power h minus 1 by h will tend to 1. Therefore, 5 times 1 will tend to 5. So it's just the constant multiplied to the function. Okay, yeah. So we got left hand limit as 5 plus m. Now, what will be the right hand limit?
4x square minus
Limit
3x.
h tends to 0 plus. Now, what will be my f of h? My h is greater than 0 here. So which function should I take when h is greater than 0?
The last one.
Last one. So limit 4h square minus 3h plus n. What is the value of n?
5.
By now we know the value of n, which is 5. Correct? Minus what is f of 0?
5.
5 divided by h. So this 5 and this 5 will get cancelled. We will get limit h tends to 0 plus this h and this h will get cancelled. This h and square will cancel. We will get 4h minus 3. And what is the value of this?
Minus
3. Minus 3.
Minus 3. So what we got is right hand limit as minus 3, right hand limit of this as minus 3, and the left hand limit as 5 plus m. So we know that this is differentiable. That means left hand limit and the right hand limit both are equal. Both should be equal. So you just equate this 5 plus m to this minus 3. What you will get?
Minus 8.
Minus 8.
Minus 3 equals to 5 plus m, which implies m is equals to minus 8. Okay. This is how we find. We got m value as minus 8, p value as 4, n value as 5. So m is minus 8, n is 4, n is 5, p is 4. So we ask you only m and p. What if m by 2? There might be m by 2, n 2 times n, p plus 8, something. We might ask many things, right? Once you get the values of m and p, just substitute that in whatever we are asking. Okay, don't confuse. Once you got the value of p, don't directly substitute the value of p. Just check what we are asking. We might ask you p, or we might ask you p by 2, or we might ask you p square. So look at the complete question correctly and answer it.
Sir.
Yeah.
So we cannot apply L'Hopital's rule until we reach the point where we prove the differentiability.
Correct.
We have to wait until this. We cannot apply this. We can say our function is continuous and we will directly put it. First need to calculate differentiability. We have to come till differentiability.
See, in this course, you no need to compute differentiability. So whatever the limits we give you, those are actually differentiable limits.
No, sir. I'm just asking in general sense because I calculated the value of m by using the left hand limit and I applied L'Hopital's rule in it. And so I think that was not a right method to do so.
So yeah, you cannot use.
Okay, sir. Thank you.
Until you are sure that both the functions are different.
Okay, sir.
But got the same answer if you apply L'Hopital's also.
Yes, sir, but we have to first use differentiability then apply L'Hopital's rule. Even if we know that particular function is differentiable, we cannot use.
Okay. So
L'Hopital's.
Yeah. So that is how you have to solve when a question is given to you like that. Okay. So look at the question completely. So when I say completely, you write from the start, suppose, to the right till the end, find the value of something. Okay. Then you start solving the questions.
Okay, sir.
Okay. Yeah. Let's move to new topic. It's not new. Maybe another topic. Allopath Rule. So whenever we are
Is
computing.
this the last one, sir? We are in a hurry.
So I
How
have an
long will it
example
take?
and linear approximation.
Okay, thank you.
So when you are computing limits of any function which is of the form f of x by g of x, if you have something in numerator and denominator, when I am going to compute the limit value at a particular point a, if you got something like 0 by 0, if you are getting something like 0 by 0 or infinity by infinity or minus infinity by minus infinity, then you are struck at that point. What we intend to say is limit does not exist. So our mind will tend to say that, so we got 0 by 0, then we can actually say this limit does not exist. But it is false. The thing is, there is this rule called L'Hopital rule, where the limit actually exists, but you cannot compute it directly. In those cases, if you know, if such a case, if you have like this, something like limit extends to a f of x by g of x, and this is you are getting 0 by 0 or infinity by infinity or minus infinity by minus infinity, then you check whether f dash of x and g dash of x exists or not. So firstly, what you have to check is whether f of x and g of x are differentiable functions or not. If they are differentiable functions, and also you know that g dash of x is not equal to 0, this particular g of x denominator is not equal to 0 in some small interval around a. So if I have a here in a smaller interval around a, so in this interval my g dash of x should not be equal to 0. So you don't need to worry about these conditions. If we are asking you the question, then obviously these all will get satisfied and you can use L'Hopital directly. What L'Hopital tells us is this particular limit extends to a, f dash of x by g dash of x, you compute the limit of this particular limit will be equal to limit extends to a, f of x by g of x. Okay. And one strong note is, if you in the first time when you differentiate it, and even then you are getting 0 by 0 form, then we differentiate the numerator and denominator until we get a determinate form. So these are called indeterminate forms, 0 by 0, infinity by infinity. So until you are able to get in real value, or you can able to determinate the value, you can differentiate it number of times. So you differentiate
So,
numerator and denominator until you get a denominator determinate form.
sir,
So this is
isn't
what.
there a function that will always give us negative values when we try to differentiate it? Apply L'Hopital's rule, indeterminate forms.
It is giving you.
No, sir, I'm just asking because there might be a condition where we might be getting these kinds of values.
Negative values.
Supposing we have a function which is e to power x divided by minus x power minus 2.
Okay, what if it keep on repeating? If I differentiate what if it is again and again I'm getting 0 by 0, 0 by 0? We have an example of that.
1 by x.
Okay. Yeah. So here is an example. So we have to compute the limits of.
Sir, one doubt, sir. Sir, when I'm doing differentiation, if I get negative infinity by infinity, so I can use L'Hopital in that case.
That is not an indeterminate form, but you don't worry about that form of indeterminate case. So we are not worried about negative infinity by plus infinity or plus infinity by negative infinity. You won't get such cases in this course. Okay.
Okay, sir. Thank you, sir.
Okay, so we have to compute this particular limit. So firstly, what I do is I will split the limits, split these terms. So I can write it like this: 9 power x power 4 divided by x power 4. Limit extends to 0, 8x power 6 by x power 4, plus limit extends to 0, 5 into e power minus 3 by x power 4 divided by x power 4. Okay. So first two limits are very easy. So what are the values of these limits? What is
9.
First one is 9.
9, 8x squared.
8x
second one?
squared.
0.
This will be x square, and as x is approaching to 0, 8x square will approach to 0. Now the main part is computing this particular limit.
This is different.
Yeah. So if you see here, when I substitute, when x approaches to 0, this particular expression will go to 0 by 0 form. You can see here, if I substitute 0 here, so this will go to minus infinite. E to the power minus infinite will tend to 0, and denominator is also 0, and this will give me a 0 by 0 form. If I directly differentiate using L'Hopital rule, if I directly differentiate this function, numerator and denominator separately, what am I going to get? 5 times e power minus 3 by x power 4 times this minus 3 by x power 4, differentiation of minus 3 by x power 4. So minus 3 times minus 4 by x power 5
Sir?
divided by
Sir, can you explain the 9 plus 0 part, please, once again? 9 plus 0. 9 plus 0.
Yeah. See here, you can actually cancel out x power 4 and x power 4, and you will get 9. Limit extends to 0, 9. What will be the value of constant 9? It will be 9 only. So you just cancel out this x. It is independent of x now.
Oh, yeah.
This value is 9 only.
Okay.
Here also you cancel out x power 4 and x power 6. You will get x square in the numerator. So 8 times x square. So 8x square. So limit x tends to 0, 8x square. So when x is tending to 0, this x takes 0. 8 times 0 square will tend to 0. So this will be 0.
Yeah. Okay. Thank you, sir.
Yeah. So this will be 9 plus. So if you see here, this particular denominator is degree decreased by 1, but this x power 5 will come to the denominator and it will increase the power by 5 times, and it will become x power 8 now. Now what it feels like is initial thing is simpler than this.
Sir, can you please explain that one? 5e to the power minus 3 by x power, how did you get that value? Minus 3 into minus 4 x5.
Okay. See, this particular thing is composition of two functions. So differentiation of e power minus 3 by x power 4 will be e to the power minus 3 by x power 4 differentiate this particular power. Okay, chain rule. Use chain rule. So if I differentiate it, this will be e power minus 3 by x power 4 times this particular thing will be minus 3 into differentiation of 1 by x power 4, which is x power minus 4. So what is the differentiation of x power minus 4? Minus 4 by x power 5. Correct? So you just check the standard differentiation.
Got it. Thank you, sir.
From there you will get this. But see, if you see here, initially we have 5 times e power minus 3 by x power 4 by x power 4. But now we got something like 60 times e power minus 3 by x power 4 divided by 4 x power 8. Now again, if you differentiate, the numerator and denominator will never come to a determinate form. It will always be in the indeterminate forms only.
Yes.
So in these cases, what you have to do is, you have to do slightly modify this in such a way that we get a determinate form. So look at here, how I will. So what I will do is, I will bring this e to the power minus 3 by x power 4 to the denominator, and I will bring this x power 4 to the numerator. Now tell me, can I write the above expression like this or not?
Yes.
Can I?
Yes.
So this.
Sir, can you please explain this last limit part, please?
This one.
ये सबसे ज़्यादा confusing है सर. ये जो आप कर रहे हैं ना, limit x tends to 0 Then S, इसको थोड़ा सा pinch out करके थोड़ा explain करेंगे, please. This is the most difficult portion I'm finding, sir.
This one or the new?
Yes, sir. Yes, sir. This one only. This one only, sir.
Okay, this thing is basically a wrong way we do. We apply L'Hopital rule. What we directly do is, whatever the numerator we have and whatever the denominator we have, if it is getting in the form of 0 by 0, what we do is we blindly differentiate the numerator and denominator, and we will check whether we get a differentiate form or not.
Okay, so we are not following the polynomials over here. We are directly applying the L'Hopital rule.
L'Hopital rule. If you apply L'Hopital rule, what we are getting is, initially we have this e power minus 3 by x power 4 in the
right, sir. Right, sir.
And x power 4 in the denominator.
Very true.
After applying L'Hopital rule, you differentiate the numerator and denominator separately. If you simplify this, what we are going to get is something like in the numerator e power minus 3 by x power 4, and in the denominator.
हाँ जी sir. अब समझ में आ गया sir. Thank you so much, sir. Have a lovely day.
Sir,
Thank
I am
you.
not getting this. How you have done this numerator from beginning?
Okay.
Sir, can you explain it once again?
Okay. Let me do it.
Hello.
Yeah, I am explaining it. See.
Yes.
If I have f of g of x, if I have to differentiate this function, what I will do is I will write
this is f dash of gx.
F of g of x times g dash of x. F dash of g of x times g dash.
Yes, sir. This is chain rule.
Chain rule. Just apply chain rule. Now my f of x is e power x. My g of x is minus 3 by x power 4. Now what is f of g of x now?
Yes, sir.
Correct?
Yeah.
So we have to find the differentiation of e to the power minus 3 by x power 4. That means
yes,
we have to find
I'm not getting this.
f of g of x of this. So what we have to find? F dash of g of x times g dash of x. So what is f dash of g of x? So what is f dash of x? So what is the differentiation of e power x? E power x itself?
1 into e power x.
Yeah, 1 into e power x, which is e power x again.
Yes.
Okay. So if it is f of g of x, what will be f dash of g of x? Correct? E power g of x. See, just substitute g of x in place of x here. What is f dash of g of
yes,
x?
Yes, sir. Yes, sir. Got
e power g of x. Correct?
Yes, sir.
Now compute what is g dash of x. You have g of x as minus 3 by x power 4. Minus 3 times x power minus 4.
1 by x cube.
Differentiation, not the integration.
Sir, it would be minus 12 by x power minus 5.
12 into x by 5.
This is minus 3 times x power minus 4. So if you want to differentiate this x power n, that will be n into x power n minus 1. Correct? N into x power n minus 1. So here
Yes,
n
sir.
is minus 4. So we are going to get 12 by x.
12 by x power 5.
Okay, g dash of x is 12 by x power 5. And this substitute g of x, e power minus 3 by x power 4 times 12 by x power 5. So that is what I have written. So e to the power minus 3 by x power 4 into 12 by x power 5. This is the differentiation of e to the power minus 3 by x power 4.
Okay, so now I got it.
Okay.
So could I ask something?
Hmm.
So this last term, it's not in 0 by 0, right? Because e to the power minus 3 by x to the power 4 can be written as 5 times 1 by e 3 upon x 4, right?
Hmm.
So then if we substitute 0, then we'll get e to the power infinity, which is 1 by infinity, which is 0. Oh,
No, what
sorry,
about
sorry,
the
sorry.
product with the x power 4? There is x power 4 also, right?
Yeah. Okay, I got it.
That will be 0 times infinity. 0 times infinity is also an indeterminate form.
Okay, okay.
Correct? Okay. So ultimately we are going to get this. We are going to complicate the thing. That is what I wanted to mention here. So if you directly differentiate using L'Hopital rule, we are actually complicating the function. We are not even getting the simpler functions. So what you have to do is some manipulation so that we will get a determinate form. Okay. That manipulation is
Sir, is it going by the first principle? Sir, do we have to go by the first principle here?
No, not necessary. See, I'm just arranging the terms which I have. If you are getting like that, then do it like this. You arrange the term, you bring the denominator to the numerator and numerator to the denominator. Now use L'Hopital rule. So now if I use L'Hopital rule, what will I get? 5 times. What is the differentiation of 1 by x power 4?
Minus 4 x raised to 5.
Power
X
I
5, sir. Yeah.
And what is the differentiation of e to the power 3 by
E
x power?
power 3
e to
by
the power 3
3x
by
plus
x power 4 into
12.
3 into minus 4 by x power 5.
Yeah. So
Correct. Now you see this x power 5 and this x power 5 gets cancelled.
and minus 4 to
Minus
4.
4 and minus 4 will also get cancelled. And this can be written as limit x tends to 0.
5 upon
5 by 3 times e to the
e to
power 3 by x power 4. Now it's easier. You just see when x is tending to 0, this e to the power 3 by 0 will tend to infinity. And 5 by infinity will tend to, see, the denominator is tending to infinite. Now the denominator is tending to infinite. 5 by denominator is tending to infinite. This will be
0.
0. Correct?
Yes, sir.
Okay, just understand this.
Sir, please explain the denominator part once again, sir.
See, denominator is same as e to the power minus 3 by x power 4. E to the power 3 by x power 4 is e to the power 3 by x power 4 and you differentiate the 3 by x power 4. So differentiation of 3 by x power 4 will be 3 times minus 4 by, see this 1 by x power minus 4 by x.
So my question: how does it tend to infinity?
Okay, so if x is tending to 0, you see this e power 3 by 0. 3 by 0. 3 by 0. Where will 3 by 0 will tend to?
Yes, sir.
Infinity. So e power infinity will tend to e to the power infinity.
Zero, sir.
E to the power infinity.
I don't know.
E to the power infinity will tend to infinity.
Yeah.
This will tend to infinity as denominator is tending to infinity.
Yeah.
So you see 1 by some large values. Infinity means large values. 1 by large values will give you very nearer to 0.
Yeah.
Correct?
Okay.
This much, or if I take this much, this will very much near to 0. This values. Correct?
Okay.
So that means that will tend to 0.
Okay.
So this particular thing it goes to 0 and finally we get the limit of this function as 9. This given limit is.
Okay.
This is how you compute limits. And yeah,
Excuse me, sir.
finally, yeah.
So what kind of function we need to alter the numerator and the denominator?
What
Is
kind
there
of?
any numerator and denominator polynomials? Here we have e power minus x formula format. So for all those functions, we need to first apply the L'Hopital rule, numerator and the denominator differentiation. If we get the indeterminate form, then we need to alter the numerator or denominator like that, or by finding the numerator and denominator polynomial itself, we can directly change the denominator form into numerator, and rearranging. After applying the first step only, here we can't get that indeterminate form, so we have to alter the numerator and the denominator.
Yeah.
So
You
by
start
seeing the function,
by seeing the function, whatever you feel, you start differentiating the numerator and denominator. But
okay,
once
after
you've
that
done it
only,
twice or thrice, you will get to know whether you are approaching to a determinate form or you are diverging. You are again and getting again and again that indeterminate.
Sir, I have one doubt here.
Once you observe that, you then come back and invert the numerator to denominator.
numerator and denominator.
Sir, one question I want to ask you.
Hmm.
Sir, a question was discussed in one live session. Log ln x square. Sir, can you write it, please?
What is?
A question I want to ask.
Which one?
It was discussed in one of the live sessions. Can you write it, please?
Regarding?
This only, sir, differentiability.
Differentiability.
Okay.
Okay, just let us do one thing. Let me complete this thing.
Oh, okay.
Anyway, this is not that important, but I wanted to take this because we have given question in. And also,
Sir?
many of you know what is linear approximation, I guess.
So I have doubt in the previous question, just you solve now.
Yeah, okay. I will take that.
Why you did the composite of the functions? Why you take the two composite? आपने side portion में एक बार composite part लिया था, तो वो हमें करना क्यों जरूरी है?
क्यों जरूरी नहीं है? In order to explain the differentiation of this e power minus 3 by x power 4 explicitly, very detailedly, I have taken composite.
Okay, sir. मतलब it was not okay not to do that part.
It was okay if you know directly the differentiation of this e power minus 3 by x power 4. If you can compute directly, there is no need to do.
Okay, sir. Thank you, sir.
Okay. So last topic is linear approximation. Don't worry about this linear approximation much, but I just wanted to tell you, complete this.
So what's the summary of the previous example? Was the original question?
It's just to compute the limits.
Compute the, okay. Thank you, sir.
Okay. So yeah, linear approximation is basically whatever the curve is given to us. At one particular point, we are going to approximate that curve linearly. But means straight line. We are going to approximate that curve as a straight line. How we approximate is, if f is differentiable at x is equals to a, firstly that should be differentiable at x is equals to a, at that point a. The best linear approximation for f at that point x is equals to a is given by this LF of x. So this is a straight line equation. If you see correctly, this is a straight line equation. So you can treat this as y also. So y is equal to,
I think it's same as tangent, right? Tangent
it's same as tangent, correct. So tangent line is the best. From there we will get that tangent line is the best linear approximation.
Can you just draw the graph also, because 4th week से if you आपने जो sessions लिए थे, आपने जो graph method बताया था ना सर, I think उससे सबको बहुत आसानी से समझ में आ जाएगा. Differentiation, integration कब करना है?
Yeah. So okay. So see, whenever a graph is given like this, you know this function, but if it is difficult for you to find the function value at this point, let's say at this point it is difficult to find the function value. What we do is, at this particular point, we try to approximate this particular function linearly. Linearly means a straight line. So what we claim is, this blue function values and this red function values, red values and the blue values approximately takes the same value around this smaller interval. So around this interval, what we claim is, even if you take that straight line or if you take that curvy difficult line, both the values are approximately same. That is what a linear approximation means. And it will turn out that the best linear, see, for this particular point, we have so many lines. You can draw so many lines passing through this point. But out of this, all the lines, which one is the best straight line that can be approximated for this particular function? And it will turn out that the tangent line we draw at any point of this function, the tangent line is the best approximation line to this particular point x is equals to a. So this particular line is the best linear approximation that I can give you around this a. And yeah, this is the best approximation for this function f, and that equation will be equal to the tangent equation, where that equation is f dash of a times x minus a plus f of a. So if you know the function, you compute f dash of a and f of a, just substitute f dash of a, f of a and a, you will get the best approximation. You have an example in the mock, question number 4. So we have given you function f of x as sine 3x cos 4x plus some root 1 plus 2x. So if I ask you to find the best linear approximation at x is equals to 0. So why we do this? Because so someone gave you this function and someone asked you the value of f of 0.02. So what will you do? What should we do?
So first we
We'll
find
use this formula.
0.02.
We'll find fa and f bar a, and then x minus a ka value we'll try find out, sir.
Right. So someone asked you this. So some people might say you just substitute 0.02 here. If I substitute 0.02 here, this will be sine 0.02 times cos 4 times 0.02. So this is very somewhat difficult. You are not able to.
It's difficult, right?
Correct. So
0.06,
this is very
how
difficult
can
to
we
find, right?
evaluate?
Yeah, this is very difficult to find. That is where this linear approximation is useful. So what we do is we try to linearly approximate this function at point x is equals to 0, and we just substitute 0.02 in that linear equation we got. So that is, even they give the similar values. Okay, so you just compute f dash of x first, and what is f of you have to compute f of 0. Here a is 0, so a is 0, so we have to compute f dash of 0, f of 0. That's it, f dash of 0 and f of 0. In order to compute f dash of 0, you need to know what is f dash of x first. So if you compute f dash of x, this will be sine 3 cos 3x cos 4x plus minus 4 sine 3x sine 4x plus 1 by root over 1 plus 2x times 2. So these are all differential formulas. So use those formulas, you will get this. Okay, this will be 1. So 1 by 2 root over 1 plus 2x times 2. 2 and 2 will get cancelled, and this is what f dash of x will be. So you compute f dash of 0 here. So f dash of 0 will be 3 plus 1. So this will be 3, this will be 0, and this will be 1. So you'll get f dash of 0 as 4. And similarly, you find f of 0. Just substitute 0 in this. So what is f of 0? You will get f of 0 as 1.
Shouldn't there also be a 2 on top? The last term?
No. This differentiation is 1 by 2
Get
times 1
cancelled.
by root 1 plus 2x times 2. This 2.
Oh, okay. Right.
Okay, yeah. So f dash of 0 is 4. F of 0 is 1. So we have all the things. F of 0, f dash of 0 is just a matter of finding best linear approximation. So what we do is 4 times x plus 1. So now see, we approximated that y is equals to 4x plus 1. This is a line that will actually be the best approximation around x is equals to 0. Now if you want to find the
Sir, excuse me, f dash x, when we differentiate, under root 1 plus 2x, so this is 2 upon under root 1 plus 2x, no?
See, differentiation of square root of 1 plus 2x will be 1 by 2 by 1 by 1 plus 2x, right?
Okay, okay. Sorry, sir.
And
Continue.
again there will be 2. For 2x, there you will get 2. This and this will get.
Yes, sir.
Okay. Yeah. So this is the best. Now you just substitute 0.02 here. So this is very easy to calculate. 4 times 0.0, this will be 1.08. So 1.0, more or less, the function value f of 0.02 will be 1.08. So very, very easy to compute.
Thank you so much, sir. Thank you so much.
So no need to worry about linear approximation. But see, what I wanted to finally tell you is worry about this continuity differentiability whenever a question is given like this. How to compute the values of m, n, p. Yeah, just let me complete. And look at the standard limits. You just remember the standard limits. And see, look at these things, floor function. When a question is given like this, how to compute the limits.
Sir, I want to ask a doubt in this question. Just you were showing. I
In
don't
this
understand this one, sir. Floor function.
Okay.
Same
So
question,
what is
sir.
it?
Even can you even give an example for ceiling function?
Okay, I will give you an example of function, but
sir, can you explain it once again, sir? This question.
Okay. So see, whenever a question is given like this, when we have any floor function given to you, just convert that floor function into polynomial function. Polynomial means like this. So n minus 1 by 2 is a polynomial function. So floor n by 2 will be
Sir,
n minus
sir,
1
how
by
have
2
you
if n
converted
is,
it to n minus 1 by 2? Can you explain it once again?
Can I?
Sir, how it is converted to n minus 1 by 2?
In floor function, we take the first value where we start. That's by n minus 1. Or in
That
ceiling, the n plus 1 by 2. Huh?
Hello, sir. Can you just please show one example of how to deal with this floor function, right? Only the floor function part. How from n by 2 it comes n minus 1 by 2.
Sir, just to write a number line and explain, sir. It will be faster.
Correct. Okay. So n equals to 1, 2, okay. See, I have given you floor of n by 2, correct? So n takes values 1, 2, 3, and so on. So tell me the sequence, how this sequence looks like. So when n takes 1, this
1
will be
by 2, 2,
floor 2 by 2, floor
3
3
by
by
2, 4 by 2.
Correct? Like this. So what is floor 1 by 2?
It's equal to 1.
Zero.
Sir, is it maximum, minimum we are talking
It should be 0, right?
Is it 0 or 1?
0.
Zero.
Sir.
Sir, just to explain. Sir, just to explain that symbol, sir, you are writing L, no? L means you have to take the lesser value.
Lesser value.
Yeah. T type means higher value.
Correct.
Like that, you just explain it.
In Hindi, you can easily. This is
Yeah, floor, ceiling. Yeah, अब समझ में आया. सही है. Yes, sir. Yes.
Ceiling is up.
Yes, Sandhya ma'am. Thank you, ma'am.
See, this is ceiling. Top one equals whatever above. You have to take the above
Ceiling is
integer.
upwards only.
Upward. So 1 by 2 means 1. Like
1,
that.
yeah.
That's all.
So you have to take the above one. You have to take the below one. For ceiling, for floor, you have to take the below one.
In case of even and odd, what will be the floor, and for ceiling function, what will be the value?
For ceiling function, ceiling n by 2 will be n plus 1 by 2.
Plus 1.
Okay. So I just wanted to ask, do you guys know the question paper or what? Why are you much bothered about ceiling things?
We are all अलग-अलग background, सब ऊपर से जा रहे हैं. डर बहुत लग रहा है. एग्जाम से पहले लास्ट मिनट पढ़ाई है और कुछ नहीं है.
Okay.
Take a ceiling function
So
exam में.
I have already given you so much hints that whatever I discuss, focus on that.
सर वही करेंगे तभी आपकी
You are
शरण में आ
running
गए.
always. I am pulling you to floor and you always tend to ask ceiling क्या होता है, ceiling क्या
Okay,
होता है.
sir. Okay. Maybe.
Okay.
Now
So
we
we will
understood.
just
Now
revise
clear.
the 2 sessions we
Everything
have
is clear
taken.
now.
Sometimes these concepts of ceiling and flow function are confusing
And
that
this
we
is
get the wrong
really the
value.
difficult concept. Ceiling and function is the difficult one till we understand.
Actually, it is confusing rather than difficult.
Can you tell me that? Can you please that one n-1 by 2 when you
Yes, sir. Yes, sir. Please explain.
See, this particular thing is 1 by 2. See, this 1 by 2. If I input 1 by 2, I am sorry, this 0. This 1 by 2. If I input n is equals to 1, that means if I input n equals to 1, I'm going to get output as 1 by 2, which is 0.
Yes, sir. 0.
If I input 1, I should get output 0. So see here, if I'm inputting 1, I'm getting half less than the value which I have inside, correct? So whatever, when n is odd, you take half, 3 by 2, 5 by 2, and so on. So this half, ceiling half, you are going to get 0. Ceiling 3 by 2, you are going to get 1. This particular ceiling 5 by 2, you are going to get 2.
The floor, right?
Yeah, 4. Sorry, floor. So see, 3 by 2, you are going to get 1. Half less than whatever the value is inside.
Small doubt, sir. We'll be round off the values, right?
Yeah.
For the ceiling and floor function, because
round off
3
the
by
value.
2 is 1.5 na?
In floor, low is
3 by 2 is 1.5 na? That's why.
Ceiling upper rounder.
Yeah.
Okay.
The ceiling function and floor function equal to same number if it is a natural number.
If it is a natural number, correct.
Yes.
See, you just worry about odd case only. For odd case, what happens is, whatever the inside you have, half, if you have half, the output value is half less than the inside value. Similarly, 3 by 2, if I have 3 by 2 inside my floor, I'm going to get output as half less than 3 by 2, which is 1. Similarly, 5 by 2, I'm going to get 2. 7 by 2, I'm going to get 3. So similarly, what I am, see this floor n by 2 is nothing but n by 2 minus half. So the inside one minus half is my output.
Basically, we are rounding off to the whole number. So
yeah,
floor means we are rounding off to the lesser one, and ceiling means higher side.
Okay, simply you can take, when n is odd, it will be in the form of 2k plus 1, correct? Some
Yes, sir.
k is from 1 to 3. So 2k plus 1 is an odd number. This is how we denote it as an odd number. So now 2k plus 1 by half. What is the k plus half? So what is the floor k plus half? So k is an integer. What will be the floor k plus half? That means k 0.5. This is k 0.5. Floor k.
This would be equal to k only.
It's just k.
It will be k. So what is k? Write it in terms of n. What is k?
It's
So
a
when n is
natural.
equal to 2k plus 1, just bring n minus 1 is equals to 2k. K is equals to n minus 1 by 2. Correct?
Yes, sir.
So this is n by 2. So I am just replacing n with 2k plus 1. From there I simplify, I will get k plus half. So k plus half is nothing but k plus some 0.5. So k plus 0.5 floor is k. I again replace k with k. I write k in terms of n. If you write it back, it will be n minus 1. So if n is odd. Okay, if n is
Srikanth,
even.
can I take 1 minute to explain easily?
Yes, ma'am. Please, ma'am.
Sure.
Please assume you are in a ladder in a room and assume ladder as a number line. Okay, you are standing in between. When you think you have a number like 1.5, look down at the floor and reach the floor. Your number line is from going up 0 to n. Whenever ceiling is there, your ceiling will be upwards. Just look upward and move on to the up. This is the easy way to remember.
मैम वन क्वेश्चन ओवर हियर, जैसे हमारा क्लोज्ड एंड ओपन इंटरवल था, इसमें आईआईटी मद्रास कभी किसी ने इतना नहीं डराया जितना इसने डराया है. सो द पॉइंट इज, कभी ऐसा तो नहीं होगा ना सीलिंग भी है फ्लोर भी है, मतलब ऐसा तो नहीं होगा ना मैम?
बताइए श्रीकांत जी.
What is I didn't.
I think he has already answered that question. He's saying focus on floor, focus on
Yeah,
floor, and we are asking about ceiling.
we'll be
So I think
humble.
Natural number, it will
he's
be
already
equal
he's
floor
been
and
answering that question.
yeah, floor and ceiling, it will be equal to same number if it is.
So can you give another
natural
example of
Excuse me,
this
sir. Sir,
floor
sir, I have
function?
one confusion, sir, in graded assignment. Are you going to take that?
Just a couple of minutes. I am done. So whatever I wanted to say is just focus on this floor cushion kind of things, and this continuity, differentiability, and limits. This kind of.
Sir, will this PDF?
I want to ask a question. Hello.
Yeah. This
What
PDF.
about
Can you give another example of this floor thing?
So
Like
another
apart
again,
from n by 2, something else.
I don't see.
Take 1.
Sir, what will be the floor function for 2 by 2?
1.5. Its floor
by
is
2 will be
1
1.
and ceiling is 2.
Okay. Thank you.
Sir, you said that 30% you will also discuss that for the exam.
Okay. See, you know exponential functions, right? What an exponential function is. When an exponential function is given to you, something like whether it can be bank interest or kind of
Sir,
thing.
I have question from the this part, the limit part.
I will come back. I will just
Yeah,
come
please,
back.
the
Let
bank
me-
interest one, which formulas we should focus here, please tell
No
me.
need to focus on formula. No need to remember formulas. If necessary, we will give you all the formulas. So
That
whatever.
interest formulas are there, right? Cumulative interest is little difficult.
Sir, which and all sine function, sir, which and all trigonometric function we have to remember, sir, in identities? Because sometimes.
That is
because,
what. If necessary, I should have already told you. It's not.
Okay, sir. Okay. Then fine.
Just discuss remaining.
Sir, discuss the
because time is less, sir.
See, yeah. So, see,
Yes,
I am done. So, what I want.
Thank you so much, sir. It has been lovely.
I want to ask a question.
Week 6.
Hello.
You're
Wait,
saying
wait.
30%, some 30%. Can you please elaborate?
Correct. I have seen 1 or 4 participants are still in this call. I expect you guys should score around 70%. So definitely just go through this PDF. You will get 70% of the marks. And apart from that, the other 30% is like you might know. You might did activity questions. If you have done activity questions.
Activities are really difficult.
Really difficult.
Till,
Yes.
Sir, can you please
graded
show
is easier than activities.
linear approximation formula?
Yeah.
Able to
But
note
sir,
that.
my question is related to logarithm equation, sir.
Logarithm equations, I will take it at
Sir,
that.
I want to ask a question
Thank
in
you, sir.
differentiability. Can you write a function, please? ln x square.
Just give
It's a sign.
You want this 30% marks or no?
Yes, sir. Kindly discuss, sir.
Sir, first discuss this.
We don't get time to solve an exam.
Okay. So 10 marks, it's just that is like the most difficult question in the question paper you might see. So that is.
Please don't give at the starting.
No, it will not. If it is in the starting, you will get to know. Srikanth
just
hasn't
discuss.
discussed this question. We can move on to the next question.
Okay.
Okay. So that particular question is from week 7 and 8 only, but it will require some knowledge in terms of sequences and limits of the sequence and everything. Okay. So that is why I'm saying limits of sequence. Focus on limits of sequence.
Activity question, sir.
Not activity question. This is the new question you will see in the paper.
Okay.
And
That
go
is
to
for current BTech students. They will do.
New question where?
So activity, if you do the activity questions, especially the differentiation part.
So what did you say for limits of sequence?
limits of
वो
sequence
भी on करता नहीं.
difficult question.
It's
where
an
you have to
important
use your-
topic. That is what Sir said.
Yeah.
Yeah.
So,
He said knew something, right?
Please
Not
let
some
him speak.
new.
Sir, you are talking about some
Please,
PDF. Which
let
PDF
him
it is?
please first.
Excuse
Sir,
me,
can
sir.
you mute everyone? We are not
There's
able to
only
see what
one
you are
dead
saying.
Just a second. Let me complete. I will tell you in detail.
Let him finish first.
Okay. So what am I telling is there is some 10% of whole 100% where one particular question you might see this question for the very first time in your question paper. You might not have seen it in the graded or activity or practice. You might see a new question that is related to limits of a sequence. If you have some, whatever we discussed only the question will be, but you have to invest some time to understand the question and do it. Apart from that, there is some AQ question. There is some this Banks exponential solving. So we give you some values, y is equals to a e to the power x. We will give you some a y, we will ask you x, or we will give you x a, we will ask you y, like this. Mostly related to bank, so interest banks kind of thing.
So
Okay, let's go through
these types of question will be of mathematical modeling where we have to apply these concepts to real world problems.
This is what I'm asking. This bank
Compound
interest,
interest,
which
sir?
formulas do we need
This
to
is
memorize?
financial.
Whatever formulas require, we will give it as a note. You
Okay,
don't
fine.
worry. See, that is what I
So
said.
there
We
are
will,
questions in the tutorials regarding to the bank
right.
function, something like that, right?
So we will give you the function, we will give you the equation, and we will give you the values. It might not be the direct value. We won't say a is equals to 100, y is equals to 200, find the x value. It will not be direct one. So you have to identify what is a in the given question. You have to identify what is y, then you have to find x, or maybe you have to find what is x there, what is a, and appropriately you find the value of y. Okay, and there is some differentiation question. We have discussed this many times, I guess. F of x times f of y. So if a question is given like this and we give you some values and we will ask you something else.
Yes. Vicky discussed earlier, and he told to keep 3 stars for this question.
Right. Maybe this might also come. See, that
He
is
explained this question.
this will all comprise.
This was asked in the previous question paper also, quiz 2.
Quiz 2. Previous
Can
time.
I ask my question?
Okay. So this will these
Please
are
let Sir complete.
Okay, these are the things will comprise of 30% and some very easy questions, log functions. Okay.
The problem is time constraint only while doing this maths question
Okay,
paper.
just a second.
Can I ask a question?
Okay. Yeah. Sorry. So log functions, even the same thing, logarithmic functions, we will give you something a, ln, x.
These logs are really difficult.
Whatever,
Sir,
we will give you the function, we will ask you some value.
Sir, in tutorial 3, week 6, it will explain SSE.
Okay, don't worry about SSE.
Now no need.
No need.
Okay.
Okay, this is what I said, right? That is up to 70%. Whatever, if you follow
and integration also, nothing related to integration.
No, that is 9th week, na?
That is 9th week, right?
Okay.
Do you expect to give us
No need. No thanks.
This is already more, sir.
The 70 to compute the 70% only, this 1 hour is not sufficient.
So for vertical,
Yes, sir. We are out of practice, sir. Last time, same tragedy happened with me also.
What happened?
Sir, actually, I started with the English paper, then it was glitching.
I know. That is why what I suggest is start with mathematics or statistics. So
Okay,
you 6 hours, right? First 1 hour is what I feel our brain works efficiently.
Right, sir. Okay,
After
sir.
CT is easy. CTE needs more thinking.
I don't know. I cannot comment about CT. That you should decide. Maybe that is difficult. You start.
It's not difficult, but needs more
No, but
thinking.
to get an
No,
idea,
CT is easy. Sandhya ma'am, CT is easy. I can, you know, we can have offline
Sir,
connect.
please explain
Abhi, sir,
activity 6.1, question number 4, sir.
Okay. Until now, this is what. So focus on this. 70% from this PDF, maybe 30% from these questions. It will cover almost 100% of the web. Might you see one new one or 1.5, maybe half part of some other question as new, but everything else is pretty straightforward, pretty common, and I expect you to score good marks.
Sir, can you
If we
explain
actually
the question?
revise the 2 sessions, if we have taken that also, we can make the most of it, right?
Yeah, that is what I said, right? This 70% will come from this.
Yes, so we will first focus on the revision sessions.
Right.
Sir, grading is done best of
PDFs are
one.
enough. Trust me. ये PDF जो revision के है ना, they are more than sufficient. Last minute you go blank. You just go to this.
Right. Okay, so with that, whatever other doubts you have apart from what I discussed, I don't focus on much on that. Don't stress. Don't waste your time. You have only 2 days to prepare. So focus on quiz 2 as of now. Focus for getting.
I don't know how to differentiate a log function. I have doubt in that.
Log function. Okay.
Yes, sir.
Okay.
Can you
Rest of the
write a
people
question?
can leave, and thanks for joining, and all the very best for your.
Thank you, sir. Thank you very much.
Thank you, sir. Thank you.
Thank you, sir. Oh, so much, sir. It was a wonderful session. Thank you, Sandhya ma'am and everyone. Thank you.
Thank you.
Thanks. Sir.
Thank
Okay,
you.
maybe I can
Thank you
take
so
some
much
5 more
for-
minutes.
Sir, can we ask some activity questions?
No activity questions and everything. Any concept related doubts I will explain.
One concept related linear approximation also, as it will come in exam, so you can explain linear approximation. Someone is asking this long time.
Sir, I don't know how to differentiate a log function.
Okay,
Can you take a question for that?
Because it's important, right?
Sir, can you please
Don't worry. Just
be wise?
just try to find the tangent. Okay.
One log function, sir.
Sir,
Yes, sir.
sir,
Yes.
sir, this
Sir, can you write a question, sir? It was discussed in one of the live sessions.
See, मैं तो एक ही हूँ.
Sir,
This it is
Please tell me
ln
that
x
everyone
square.
attend that.
Calm down, everyone. Calm down.
See, I cannot hear you,
Sir.
and it is going to waste your time also. See, I
Sir,
was
it is
supposed to
ln
close this
x
session by
square.
10:15. I already mentioned you 10:30 से और एक session होने वाला है. So we have to go close this session.
Yes, sir. It's a short question, sir. Can you take it ln x square? Write it again, sir. It is ln x square.
Sir, this session PDF you are going
Yes,
to
sir.
upload?
Sine of this whole function. Then sine of this whole function.
What is sine
ln
of
x square? Sine of ln x square. That is what I want to
Okay.
say. Sine of ln x square. Yes, sir. X square and whole function square.
Whole
function square. Sir, square of from sine to ln x. Yes, sir. This. Sir, how do we check its differentiability? How do we approach this?
How do you differentiate? Okay, एक बात बताऊंगा. Why are you going this complicated? Did we give this thing?
Sir, I don't understand how the chain rule is applying in this.
Chain rule. This is
Yes.
chain rule of 3 functions. Composition of 3 functions. So y dash will be 2 times sine ln x square. Okay, let me complete. complete, then I will
Yes,
tell
sir.
you what happens.
I consider whole function as sorry, x square. This is 2 into x power 1.
2 into x, okay. Now inside part should be differentiated. Inside part, if you want to differentiate, that will be cos ln x square. Okay. Sin x will be differentiation cos x.
Yes, sir.
Okay. Now inside ln x square, you should differentiate ln x square. This is 1 by
X
ln
square.
x will be 1 by x square.
2x.
So now
I don't understand, sir, how you have written this.
ln x is 1 by x, na?
Okay, sir.
Now ln x square is 1 by x square, and inside part you should differentiate again. This will be 2
Into 2x.
That's it. So yeah, this is how
model,
this,
sir.
no need to go in these deep or this part.
Okay.
Okay.
What is
Sir,
1 by log x differentiation?
1 by log x.
Yes. How do you differentiate this?
U by v. Use u by v.
We have discussed 3 log functions in this session, sir.
Hmm.
So is this enough to focus on those functions alone in log? So ln
Enough.
of x,
Enough.
ln of x plus 1 into x minus 1, and another function is ln of x square minus 5x plus 4.
That is sufficient. That is sufficient.
Okay,
That
okay,
means
sir.
you have to know how to find the vertical asymptote of an log function.
Okay, sir. Nothing much. This graph will not be used anywhere, no, sir. Because
Most probably no. See, some might use graphs and solve the problems also, but not necessarily to use graphs.
yes, sir, because it becomes tedious when 0 to
Okay.
1 interval, 1 to 2. So
Yeah.
that kind of.
Okay.
Sir,
sir,
Sir?
can you please ask
today whatever
week 7.2 question number 11, sir?
you
See,
said,
Small
Activity
doubt.
7.2 question number 11, sir.
that is what I said. Don't now don't go see the activity questions. If you have
In the
just post
Sir,
it.
in your linear approximation problem, hello.
Uh-huh.
In your linear approximation problem today, how can you differentiate d by dx of root under 1 minus 6? Due to network problem, this one, 1 plus 2x, root under.
See, 1 plus
I
2x
cannot
is
follow your, yes. How
this
can
will
we
Sir, I have the
differentiate?
same question in this linear approximation. Can you repeat this solution? Solve more question number 4.
Only that
Can you
part,
repeat
sir.
the solution?
okay. So okay, rest of the people due to time constraint, I'm unable. I'm going to take this as the last question. So focus on what I said. If we have a new session after quiz 2, we will come back to this. We will have 2 or 3 revision sessions in the end. At that time, we can discuss more on week 7 and 8. Okay.
So one small suggestion, sir. From week 1 to 4, should we concentrate more some basic concept like 1 to function, onto function,
Did
transitive?
I ever mention weeks 1 to 4 in any of my live sessions? Even we won't be using the direct questions, but we might use the polynomials, those kind of.
Okay. Okay, sir. So not to focus more on those terms, no, sir.
क्या ये solution PDF upload करेंगे आप?
Yeah. Hey, yeah, thanks. So this mock
Already
question
there.
for solution PDF is available. I have written in a detailed way only. You can just
sir, actually ना solution
Can
उसमें
you please repeat this
सर उसमें
solution?
केवल question
By-
है, solution नहीं. वो
Keep on
इसलिए
asking.
solution PDF इसलिए बोल रहा हूँ.
PDF नहीं है.
सर इसका जो पीडीएफ आपने डाला था ना, एक्चुअली इसमें सॉल्व वाला क्वेश्चन का ही क्वेश्चंस आपने दिया था, दैट हैज नॉट बीन सॉल्व्ड.
So this one can, hi sir, please
please
can you explain this question one more time?
Okay, let me be more clear. Linear approximation से
This PDF I will going to say today's class PDF because whatever last time you uploaded, no, that does not have the.
It is there already.
No,
It does
it is
not have the solutions.
solutions is-
Yes.
So today's
Only
PDF.
questions are there.
Sir, could you please upload the today's PDF because it has some solutions. It will help us.
Sure. This PDF also I will upload.
Thank you very much, sir.
Okay. So this thing you might confuse here. How to differentiate this thing? So square root of x, f of x, if it is square root of x, differentiation of square root of x is 1 by 2 into 1 by root x. Okay, this is what we apply here also. If I am going to differentiate this, then this will be, this is uv, use two functions. So f of g of x, f of x times g of x. That will be f dash of x times g of x, which is 3 cos 3x times cos 4x plus f of x times g dash of x. So this is sine 3x times cos 4x differentiation will be minus 4 times sine 4x plus this particular root 1 plus 2x is 1 by 2 into 1 by 1 plus 2x times 2. This and this will get cancelled, and this is what f dash of x is. Now we need f dash of 0. Just substitute 0 in this equation. Just substitute 0 in this equation. We will get f of 0, f dash of 0. Best linear approximation will be.
Thank you, sir. This is simply the chain rule, na?
Yeah, simply the chain rule.
Thank
So
you.
this is how you will.
Sir, in this question,
In the question
see,
about this,
sir, in this question, mock question number 4, if we look, then there is a unique linear approximation exists. Such type of option were there.
Yeah. See, we are going to get only one linear approximation, right? Best linear
So,
approximation.
but as we know that linear approximation will always be unique. So why there we only
see,
confused?
just to make it MSQ maybe.
Answer is just 4.
Huh?
Answer is 4.
Answer is 4x here. It is 4 and
Okay.
Okay. Okay. From here, I'm so sorry. I'm running.
Thank you so much, sir.
but one last question in the PDF only. One last question. Just only take 5 minutes.
Even not, see, 10-15, see, someone is asking to start.
Just 5 minutes.
Okay, just
In the
ask me.
PDF, in the PDF.
Yeah.
At one point, this I could not understand the solution. Can you tell me? Can you?
Where is that? Which is that?
If you go up just above the linear approximation. Yes, above the linear approximation. Yes, this one. Here you have landed at 5 into 1 by x power 4. Can you explain from here? Just, if you don't mind.
1 by?
5 into 1 by x power 4.
Okay. See, I just brought this denominator to the numerator. So 1 by x power 4, I can write it as 1 by x power 4 by 1. So I brought this x power 4 into the numerator. Can I? I can write it, right? This x power 4, if I bring it in the numerator, I can write it as 1 by x power 4. And I brought this e to the power minus 3 by x power 4 as
I'm
difference.
not able to connect from where you got this. That's why.
From here.
Okay.
From here,
Yeah.
I just brought this denominator part to the numerator. So 1 by x power 4. In denominator, it is x power 4. If I wanted to bring that into the numerator, it will be 1 by x power 4.
Yes.
Similarly, e power minus 3 by x power 4. See, when I bring it to the denominator, it will be
that was a
e power.
manipulation.
Yeah, I just manipulated it. Yeah.
Okay, sir. Thank you.
Okay.
The session was really good, sir. And one more thing I just want to add. The PDFs what you have given, if we follow them, it's more than enough, sir.
Yeah, more than enough.
Yeah. Thanks a lot.
Okay.
Please upload the total PDF with solution.
Sure.
Completion of the yes.
Even for previous solutions also, last revision session solutions also.
That is there.
That is already uploaded.
That is already there, sir. Now this only is not.
Yeah, we will upload this. Okay, thanks.
Okay, sir. Thank you so much,
sir.
All the very best.
Sorry, sir.
Thank you so much.
Thank you, sir.
Yeah.
Hello.
Then it's very commendable that
Thank
the
you,
effort
sir.
you put to make everything so simple, especially the efforts. I mean, we can see it in the PDF that you made. And
Yeah,
both
it's
you and
so
Vicky,
good.
sir.
So
I
good.
mean, it's very commendable. Thank you so much.
Hello.
Thanks. That's a great compliment.
Hello.
Hello.
Sir, I wanted to ask, like, in that, like, graded assignments will be considered for 10%, right?
Right.
And like it will be like best out of like all 12 or 13 will be counted, right? 7 or
Best that you need to check with support. That is for end score eligibility, I guess. Best. I don't know. 7 out of 11. No?
Best of 7 out of 11.
Best 7 out of 11. But for eligibility, it is for best 6 out of 9 or something.
okay.
Got it.
Okay.
Okay. Thank you. Vicky
Thank
joined.
you, Srikanth. Thank you so much.
Thanks.
Thank you again.
Thank you. Thank you.
Thank you, sir. Relax.
Bye bye everyone.